Hello, this is Mr. Reese, and this lesson is going to focus on solving trigonometric equations that involve quadratics and factoring. And why don't we just get started right away with one of the questions here. Let's say that we have something like this. Solve for x with the angles ranging from 0 to 2 pi. Now, since it says 2 pi, this is a big hint here that your answers are going to be in radians. Now, you might notice that this is a quadratic, and because we have something squared, what we want to do is we want to set one side to 0, because that's typical for quadratics. So let's go ahead and do that. Minusing these two over to the left-hand side yields this. Now, you should notice that each and every single term is divisible by 2. So why don't we make this a bit simpler? Divide the entire equation, including the 0, since we have two sides, by 2. There we are. Now, again, note that this looks like a quadratic, except for one thing. This would be the form that we would ordinarily expect, y squared minus 2y minus 3. This is almost the same thing, except, first of all, it's the sign. Secondly, it's the sign of the variable, so we can't just say x squared and then minus 2x minus 3. But that doesn't mean that we cannot solve it out the same way. If this were your problem, what you would do is you would solve this either by factoring or by using the quadratic formula. In this case, we'll factor. That's y minus 3 and y plus 1. And then we would use the zero product rule, which basically means that we would take this and this, set them equal to 0, and then solve for y. This is really no different. You would treat this as if we're an ordinary quadratic. Take that and factor it. And instead of writing y, you would put sine x. So instead of y minus 3, it's sine x minus 3. Instead of y plus 1, it's sine x plus 1. And we would use the zero product rule and solve. So sine x minus 3 sets equal to 0, and you get 3 for the sine of x. Here you'd get negative 1. Now, unfortunately, this doesn't end the problem here. We need to draw a figure for each of these two values. And let's first start off with the sine of x equaling 3. At what angle does the sine equal to 3? Well, there are no answers that'll give us that. Remember that the domain of values for the sine goes from negative 1 to positive 1. 3 is a little bit beyond that, and if you recall the graph for the sine, the amplitude typically is 1, so it doesn't go as high as 3. For negative 1, or 1, if you were to determine the angle using the arc sine, we would have to rely on the unit circle. This is the unit circle, and you have to think, where do we get the sine being negative 1? Well, it would be down here. Recall that it goes cosine, then sine. The y value being negative 1 is what you're looking for. And this angle is 270 degrees. Or in radians, that would be 3/2 pi. And that's really it. Now, a word of note. What if the question called for all solutions of x? Well, if that was the case, then we would have to account for it not just being here at 270, but also the possibility that we would keep going around again, another 360 degrees, or 2 pi, then around again, and so on and so forth. To account for all those coterminal angles, we would tack this on, plus 2 pi n, and if you were in degrees, you would write 360 n, and we would state that n is an integer because we want this to be a whole number of times that we would go around in a circle. We would state that it is an integer because we could also go around in the negative direction. So that's really your answer. Keep in mind, though, that our domain of answers is from 0 to 2 pi. We satisfied this already. So leaving your answer at this is enough. As far as how it would look graphically, consider the graph for the sine. This is the ordinary graph for the sine wave. Now you'll notice I wrote just simply y equals sine x because, that's what we're getting here essentially, sine x, sine x. You'll notice that the amplitude is 1. That's as high as it goes. It doesn't go up to 3. That again reconfirms why we don't get 3 for an answer. But where is the sine negative 1? Down here. So at what angle are we talking about? In other words, what's that tick mark right here? How far across do you go before you go down to negative 1? That's 3/2 pi. And that would be it. Again, this thing stops at 2 pi because remember, the domain of values only stretches to 2 pi. But if it says all solutions of x, then we would assume that this graph just keeps on going. So we would have not stopped at 2 pi. We'd have another one there, and another one here, and so on and so forth. And my marks don't seem to match, but you can kind of get the idea. What it essentially is then, where is it also at negative 1? It's at negative 1 here, not just here, but here, also here. And because of that, you would want all these angles to go with it. And remember, the period of this is 2 pi. So therefore, you have to think, well, if the period's 2 pi, that means if we go another 2 pi units, we get to the next answer. And another 2 pi units, we get to the next answer. So that's why you would tack this on. Again, though, our question doesn't ask for that. It just simply says to stop at 2 pi. Therefore, we know that this isn't going to be tacked on. And we also know that the rest of the graph isn't going to be tacked on as well. So hopefully that helps make things a little bit clearer with respect to graphing and how that connects to equation solving. Let's do another. Solve for x. This time we want our answers between 0 and 360 degrees. That means our angles are in degrees. Upon first glance, the tempting thing to do would be to divide both sides by cosine. And this is perfectly fine only if we don't end up reducing out the cosine on both sides. In other words, the one that we actually divided by gets reduced out. If you do that, then what happens is this. You end up losing answers. So we really don't want to approach it that way. However, that also is a hint on what to do. If you can divide it out from both sides, you can also factor it out. But in order to factor it out, you also need to set one side to 0. So you're going to have to minus it over to the other side. Then go ahead and factor it out. That first one, if you factored out the cosine, you'd be left with just 2 sine x. Here, if you remove the cosine, you'd just get 1. Okay, let's use the zero product rule. If you set cosine x equal to 0, well, we get one answer. If you set the second group equal to 0, we get a second answer. Let us first focus on the cosine of x equal to 0. Just for the record, if you get 0, you should be thinking unit circle. So where's the cosine 0? Well, remember the cosine is the x value for the unit circle. So the two particular angles in question are here at 90 degrees and here at 270. That does it for that one. What about the sine being 1/2? Well, we can't use unit circle in this one. Remember, that's really just for zeros. So let's consider what quadrants is the sine positive in, since it says positive 1/2. Well, the sine is definitely positive in quadrant 1, so let's start there first. Let's get this reference angle here. What is the arcsine of 1/2? If you got a calculator, that will spit it out for you, or of course you can just simply use special triangles. It's 30 degrees. Now also consider where else is the sine positive in. It's also positive in quadrant 2. So just simply draw the angle in quadrant 2 there and put 30 degrees where the reference angle would normally go. So those are your reference angles. So now consider this. Now that we know the reference angles, what are the actual angles? Well, starting from here, it's pretty obvious this first one's 30 degrees. So there we are. And then consider this angle. How many degrees is that one? It's 150. And like that, we are done.
She's a lady. Oh, she's a lady. Talking about that little lady.
Okay, let's try this one. 4 sine squared x plus cosine x minus 1 is equal to 0. I want you to note that up here, we're just simply going to find angles ranging from 0 to 360 degrees. I'm going to focus really just on starting this and spending more time on that and a lot less time on walking through the problem. First of all, I want you to note that we have sine squared, and that's different than cosine. So we have a formula for sine squared. Let's go ahead and replace that. And that's 1 minus cosine squared. Now it's 4 times this, so go ahead and distribute that. Then collect your like terms. And by the way, if you didn't see it, for negative 1. So now what we have is this. Our leading coefficient is negative, so we're going to multiply this entire equation by negative 1. And now it's in quadratic form. So now we're free to factor this. And now that it's factored, we can just use the zero product rule, which says we can set this equal to 0 and set this equal to 0 and get our solutions. That's the first part. And that's the second part. Let's turn our attention to this one first. The cosine of x is equal to 1. So what's the angle where the cosine is 1? If you're seeing 1s and 0s and negative 1s for the cosine, you should be thinking unit circle. Recall that for the unit circle, the cosine is the first number, the sine is the second value. We're looking for where the cosine is 1, which is just right here. So that angle right here is 0 degrees. And if you're thinking that's also 360 degrees, you would be right except for one thing. We are told to leave 360 out of it, so we don't include 360. We go from 0 degrees all the way up to 359.999. Turning our attention to negative 3/4, what we want to do is get the arc cosine of positive 3/4. And we do this only because we want the reference angle. If you punch that into your calculator, you get approximately 41 degrees. Now, the thing to consider is this: where's the cosine? Negative. Well, the cosine is positive in these quadrants. Therefore, quadrants 2 and 3 are what we're interested in. Let's go ahead and draw in those reference angles. There's the one in the second quadrant with the 41 degree angle. There's the third quadrant with the 41 degree angle. So now it's all about getting the actual angle, because these are not the real answers. The real answers span from here to here. So the question is this: if it's 180 degrees all the way to the left, then if you fall 41 degrees short, you should get 139. Likewise, for the third quadrant angle, if you were to span from here all the way to here, you should get 221. And that does it for that one. Okay, here's another one for you. This one's a cubic. What we're going to try to do is we're going to try to factor this by grouping. This is how you want to view the problem. So if you're going to factor by grouping, you would first try to factor those first two, and then you'd factor the next two. For the next two, make sure you would just simply factor out the negative. Since these two are the same, we can keep going. And now that we have that, we can use the zero product rule. For y squared equals 1, you take the square root of both sides, and you get plus or minus 1. Therefore, the sine of x is equal to plus or minus 1. For the other one, you get y equals 1/2. Therefore, the sine is 1/2. And then from there, you would just figure out your various angles. For the plus or minus 1, you have to think, where is the sine 1 and where is the sine negative 1? Just use the unit circle for that. And you get 90 and 270 degrees. For this one, you have to think, where is the sine positive? That would be quadrants 1 and 2. The reference angle is 30 degrees. So there we are with our solutions. Okay, let's do one more. Solve for x. You'll notice that with this one we have multiple angles here and single angle here. We don't want to have that dynamic. What we want is all the same kind of angle. They're either all double or all single. So what you're going to do is you're going to substitute in something for this guy. If you're thinking cosine squared minus sine squared, you're ignoring the fact that there's a cosine over on the right-hand side. We really don't want to mix the cosines with the sines. We really, if possible, want to have this as all cosine or all sine. This one doesn't help us either. So this version of the cosine 2x formula is the one we want to go with. Go ahead and minus the cosine from both sides, then factor, then use the zero product rule. That's for the first one, and that's for the second one. From here you just want to get all your angles. For this first one, you look for where the cosine is negative, then get the angles for those two quadrants. By the way, notice that I'm in radians. And then for this one we get 0. And that's it for that one. That's it for this one. I'll see you next time.